Next, we're going to talk about soldering XLR connectors. And XLR connectors are going to be a very familiar connector as you do a lot of line level audio, microphone level audio, as well as some of the other things that we do as well. Connections to amplifiers, input connections to amplifiers. So you'll see XLR connectors in a lot of different audio applications. So we're going to do both a male and a female XLR. The first connector we're going to do is going to be an XLR male connector, and we're going to put it on this twisted pair wire here. So let's go ahead and begin to prepare our wire. I'm going to go ahead and begin by removing the outer jacket here. Well, how much jacket do I need to remove? Well, we'll see if we can do a little test fitting here in a moment, and we'll find that out. So I can remove the outer jacket. And what I find under here is a little nylon strain relief. I'm going to go ahead and remove that. And cable construction will vary a little bit. The way this one is, the drain wire that we know is actually on the outside of the foil shield here. So I have my drain wire. I'm going to go ahead and twist these strands together while they're here. And then I can go ahead and remove the foil shield. And sometimes these remove easily and sometimes they require a little work. So I can take this off. And now I have my twisted pair here with the shield. I'm going to set that aside for a moment just here in the vise. And we're going to take our XLR connector. I'm going to go ahead and open the bag, take all the parts out, and we'll inventory what we have here. Manufacturer styles will vary a little bit, but I'll still have the same basic components here. I have the outer shell, I have an insert, I have a boot, and I have a strain relief. One of the things that's going to happen here as I apply the boot here to the strain relief is this part is actually going to start clamping down on the outer jacket. And I want to make sure that I'm clamping down on the outer jacket and not the individual conductors. So as I begin to, and if you've ever done models as a kid or something like that, when you would do models, you would test fit certain things. So I'm going to test fit here the strain relief up against the insert and compare that with the cable. And that'll give me an idea, okay, I want to make sure the cable comes up, or the outer jacket comes up so that I'm not clamping on the individual conductors but the jacket itself. So that gives me an idea of about how long these are going to be. So I can go ahead and trim these to length now. And the other thing we're going to need to know is, okay, I have my black, my red, and my shield. Where does the shield go? Well, according to the standards, the shield always goes to pin 1. So I'm going to identify on this connector which one is pin 1. And it should be marked here on the front. In this case, this is pin 1 over here. So we're going to take, as I turn this around, pin 1 is going to be shield. And then I'm going to take my red and go to, whoops, there we are, pin 2, and my black to pin 3. So I've got my conductors to length. One of the other things I need to do before I make this connection or begin to go ahead and tin the wires and things is make sure that I have everything I need on the cable. In this case, one of the first things we're going to put on is the actual boot. So we're going to go ahead and put the boot on the cable. And like many of our other terminations, we're going to be using some heat shrink. So I'll go ahead and put my heat shrink on. And what that's going to do in the end here is it's going to help add some strain relief to the transition point where the cable actually comes outside the boot. So I've got my boot, and I'm going to put my heat shrink on. And then I can begin to remove the jacket from these individual conductors. Now, how much jacket do I need to remove from these individual conductors? Well, this is another little test fit here. If I put these inside the cup, I'll get an idea of how far inside those cup the conductors will go. And the standard, not standard, but best practice here as far as how much jacket to remove is between the actual cup, physical cup, and the jacket. I don't want to see any more than 1 times the diameter of the individual cable that I'm doing here. So I'm going to be stripping about that much jacket off of it. So let's go ahead and take our wire strippers and we'll begin to remove the jacket off the individual conductors. Probably need to remove a little more than that. So we've done our red. Let's do our black. So I'm going to go ahead and put my wire into the vise here so it'll hold it. And we're going to take the iron out. We're going to clean the tip, either by sponge or the little wire tip cleaner. We're going to add a little solder back to the tip. It's going to do 2 things for me. One of which, it's going to keep solder on the tip itself, but having some solder on the tip is also going to help with the heat transfer from the iron to the material itself. So let's go ahead and tin the first wire here. I'm going to apply the iron to the back side of the conductor and then actually apply the solder to the conductor itself. Now, as far as the drain wire here, I'm just going to tin the tip. I don't want to tin all the way down because then I'm going to lose flexibility in the wire as I'm trying to assemble this together. So just like we did the other ones. All right, so I'm going to go ahead and clean the tip, put a little solder back on the tip, and put it in the holder. Next, we're going to prepare the connector. We're going to set this aside for a second. And the way we prepare the connector is to go ahead and put solder actually in the cups themselves. So we're going to begin by putting solder in all 3 cups. Again, I'm taking the iron out of the holder. I'm cleaning the tip. I'm going to apply a small amount of solder back to the tip. And I'm going to get the cups hot and actually flow the solder into the cup itself. So we're going to get the cup hot, and then we're going to flow the solder actually into, and what I'm doing is I'm laying the iron actually across the top of the cup to get the cup hot. And clean the iron off a little more, apply a little more solder to it, and again the same procedure. Is I'm not flowing solder onto the iron, I'm actually flowing it into the cup itself. Now, how much solder do we put in the cup? Well, if you look at the industry references, it says to fill the cup, not to overflowing, but to fill the particular cups that we're doing here. All right, so now that we've filled our cup, let's go ahead and get our wire back. And one of the things I'm going to work with is I'm going to start here by doing pin 2. Let's make sure that we kind of have these pre-positioned here. And the easiest one to do is actually the first one. So again, cleaning the tip off, applying a little more solder to the tip to help with heat transfer, and then we're going to go ahead and put our first one in. And then we're going to remove the heat, we're going to let it cool down on its own, and we're not going to move anything as it cools so that we get a nice solder joint. All right, so that's our first one. Now I need to kind of pre-position this next one here in the cup. So I'm going to hold my fingers back here and actually move the conductor into the cup. I don't want to hold my hands here because that's going to get very hot, isn't it? So I'm actually going to pre-position this a little bit so that when I melt the solder here, I can actually work that into the cup, just like that. And we're going to let it cool down. And once it's completely cool, I can go ahead and remove that. Again, making sure the tip is clean, applying a little solder back to it before I put it back in the holder. Now before we do the shield here, one of the things I'm going to do is I'm going to apply a little bit of heat shrink on this shield. The reason we do that is sometimes as we assemble these XLR connectors, things will twist inside, and if things twist, I could actually end up with a short between the shield and one of the conductors. So I'm going to use just a little bit of the very small heat shrink. Sometimes we actually call this spaghetti because it's so small. I'll use a little bit of heat shrink here, and I'm going to go ahead and put it onto the drain wire. And again, just like we did the other connector a moment ago, I'm going to kind of pre-bend this a little bit so that I can put it directly into the cup. Let's remove just a little more of that. That looks about right, because I want to make sure I keep my fingers away from the heat. This is also why we don't tin all the way up, because if I do that, then I've lost my flexibility. All right, that looks like we can do that. Again, cleaning the iron, applying a little solder back to the tip, and then we can go ahead and put the drain wire in. And then we're going to let it cool down. And that's what we have so far. Now I'm going to go ahead and bring my heat shrink into this, and before we shrink it down, let me show this. We're going to shrink down the spaghetti here on the drain wire, and then I'm going to bring this other piece of heat shrink up and cover this joint here so that I don't have any drain wire exposed. So we're going to go ahead and shrink all this down, fire up our heat gun. So that's what we have so far. Let's go ahead and complete the assembly. Here's our strain relief, and this strain relief actually has a slot in it, which makes it nice. So I can go ahead and put this on the cable at any point. So we have that, and this slot here will actually line up with the tab that you see here. And then we can put the body on from the front. And again, all this is keyed, so it's only going to go in one way. And I mentioned before the strain relief, and you can see here, if you looked real close, you could see some serrations here. And we see that these serrations, as we put the boot on, are actually going to clamp down on the heat shrink and the cable jacket itself, not the individual conductors. So let's go ahead and bring our boot up, and then we can make the assembly here. All right, and you can see where the heat shrink comes out of the back here, helping provide some strain relief for this transition out of the boot. So that's our XLR male. Now we're going to do a female XLR connector. Let's go ahead and open the bag here and inventory the parts. And again, styles will vary a little bit, but it's all the same basic thing here. This is a little different than the male XLR, but we still have the body here, we still have the strain relief, we still have the boot, and we still have the insert. And as we'll see, the cups here are a little different on this particular female connector as compared to the male connector that we did earlier. You can see the high flanges on this particular connector that we didn't have on the other connector. And what I'm going to do is I'm actually going to lay the iron across the top of these flanges, and that's going to get the cup hot as I flow the solder into it. These cups are also a little different in that they are lots deeper than what was on the male XLR connector. So filling the cup the same way, we're not going to be able to quite do that. So we'll fill the cups, go ahead and prepare as we would the male connector, but we're not going to be able to put as much solder in. So let's go ahead and begin preparing our cable just like we did before. And we'll go ahead and remove some of the outer jacket here. So there's our outer jacket. There's that nylon strain relief that we can remove. We should find our drain wire in this particular cable on the outside of the shield. So there it is, and we'll go ahead and twist those conductors together. We'll go ahead and remove the foil shield. Sometimes this tears off real easy, and sometimes it takes a little effort. All right, so how long do these individual conductors need to be? Well, as I assemble this, do a little test fit, I can see how it's going to go together. And I want to make sure that the strain relief here in the back is actually going to be clamping down on the outer jacket and not the individual conductors. So this tells me that I probably need to trim about that much off. Keep my finger on the other side so pieces don't go flying. And that's what we have so far. Okay, before we do anything else, let's go ahead and put a few things on this cable. We're going to go ahead and put our boot on. And we're also going to put our heat shrink on. And we want to make sure that the heat shrink is long enough that and when we assemble it all, that it comes out of the boot here at sufficient length. The heat shrink is going to help us with the transitional strain relief here in the transition between the boot and the cable jacket. All right, so let's go ahead and begin working with our individual conductors here. We'll take our wire strippers and remove the jacket off the individual conductors. We can even twist them together a little bit. All right, so we're going to place our wire here in the little vise to hold it still for us, and we're going to go ahead and tin the wires. We'll take our iron out of the holder, we'll clean it up on the sponge, we'll apply a little solder back to it, and I'm going to place the iron actually on the back side of the conductors and flow the solder into the conductor itself. Oops. And again, we don't want to tin all the way down the drain wire here because we'll lose flexibility when we try and put it in the cup later on. So just like we did the other conductors, we tin just the very end. All right, so we'll clean off our iron, put a little solder back on the tip, and put it back in the holder. All right, let's go ahead and prepare our connector here. So here are our cups. We'll put it in the vise. And just like the male connector, we need to identify which one is pin 1. So we'll see here, that one is pin 1, that one is pin 2, and that is pin 3. So in this case, pin 1 is going to be closest to me. So I'll go ahead and put this in the vise. And we'll pre-position our conductors a little bit here. Pin 2 is going to get the red, pin 3 is going to get the black, and our shield is going to get pin 1. All right, so let's go ahead and prepare the cups here. Now this is a little different than the cups for the male connector. If you look at these actually have little flanges on them, and we really didn't have those big flanges on the male style connector. So what we're going to do here is we're actually going to lay the iron across those flanges, and that's actually going to heat the cup for us and to make it easier for the solder to flow into. Now this particular style has some very deep cups, so it's going to be a little more difficult to try and fill the cups as we do with the male connector. So this is going to be a little different. We're going to take our iron out of the holder. We're going to clean it off on the sponge, and then we're going to apply some solder back to the tip. Again, this is going to help the heat transfer from the iron to the cups themselves. And we're going to go ahead and begin putting solder in these cups. Again, I'm just landing the iron on top of the flanges. And I'll do this for each one of these cups. Your iron may get a little dirty in between, so I'm going to go ahead and clean it off, add a little solder to it, and then I can come back. And again, I'm touching the solder to the cups, not to the iron. And we'll do the last one here. Add a little solder for heat transfer, or aid with the heat transfer, and see it begins to flow much easier. All right, come on now. I'm going to get off of this for a moment because I don't want things to get too hot. I'm going to give it a moment to cool down, clean my iron off, and then go back at it. There we go. All right, so our cups are prepared, and we're going to go ahead and begin putting our conductors in the individual cups. And then try not to move it as it cools. And then for the second one, let me put the iron back in the holder. I'm going to pre-position this a little bit so that I'm going to keep my fingers back here and actually just work this into the cup. Take my iron out, add a little solder to the tip. Work my conductor in, remove the heat, let it cool on its own. And the last one we're going to do here is the drain wire. I'm going to put my iron back in the holder, and we're going to add a little bit of very small heat shrink to this part of the connection, or this part over the drain wire. So let's go ahead and trim off a piece of small heat shrink. The idea here is that as we assemble this, we want to make sure that in case the wires get twisted in here for whatever reason, we don't inadvertently end up with a short connection between the drain and one of the other two conductors. So that looks about right. All right, take the iron out. Tin the tip. And again, just like we did before, kind of pre-position this a little bit so I can keep my fingers back somewhat. It looks like that'll work. Allowing the solder to melt in the cup. Put in my drain wire and let it cool. Okay, clean off my iron, put a little solder back on it, and I can put it back in the holder. The next thing we're going to do is actually bring in the heat gun, and what I'm going to do is I'm going to shrink this part first, and then I'm going to bring this part up, cover this transition between the drain wire and the jacket, and I'll shrink that second part down. All right, so we'll bring our heat gun over. right, so now I can go ahead and finish my assembly. This particular strain relief has a little slot in it, so I can actually put this on the cable at any point. Makes it very convenient. So we'll go ahead and put that on the cable. And this is keyed, so it's only going to fit together with the insert one way. And then we're going to put the body on. We're going to put the body on. And again, this is keyed as well, so it's only going to go in one way. In fact, with this little connector, sometimes it helps to turn it upside down for the latch. And I'll fit in the rest of the way, and then I can go ahead and bring the boot. And if you look real close, you could probably see some serrations here. And we want to make sure that these serrations clamp down on the actual jacket and not the individual conductors. So we've done a good job with the proper length there. So I'm going to go ahead and bring the boot up and finish the assembly. And you can see the heat shrink coming out the back, helping provide some strain relief for the transition between the boot and the rest of the cable. So that's our female XLR. All right, so we finished making both our male and our female XLR. So we've made a twisted pair with shield XLR to XLR cable that we can go ahead and put in the system. Now, one of the things that we're going to do, like we do with any cable assembly that we make, is we're going to test it first before we actually put it into our system. So we're going to test it, and after that we're good to go.